Okay, my GCSE maths folks, okay, looking at some surds in this video, okay, so this is from aiming for a grade 9 booklet, okay, looking at some grade 9 topics, okay, looking at expanding and simplifying with surds, okay, double brackets, rationalizing the denominator, okay, obviously working with surds, okay, so expand and simplify 2 plus root 3 times by 2 minus root 3. Give your answer in the form a plus b root 3, where a and b are integers. So yeah, integers meaning your whole numbers, okay. So I'm going to explain obviously using FOIL. So I'm going to do 2 times the 7 makes 14, okay, and then 2 times minus root 3 makes minus 2 lots of root 3, so minus 2 root 3. Then I've got positive root 3, yeah, so plus root 3 times 7, okay, makes plus 7 lots of root 3, so plus 7 root 3. And then positive root 3 times negative root 3, so positive root 3 times minus root 3, okay, makes negative or minus root 9, okay, which is just 3, okay. So remember, yeah, so if I've got root a times root a, okay, that just simplifies just to a, okay, because essentially I've got root a all squared, and the square root and square end up cancelling each other out, okay. So yeah, root a times root a is just a. Okay, final step now, guys, is to collect like terms. So remember, numbers go with numbers, surds go with surds. 14 minus 3 makes 11. And minus 2 root 3 plus 7 root 3 is plus 5 root 3, or positive 5 root 3. Okay, and that is expanding double brackets with surds. Okay, hopefully it makes sense. Next up, we're asked to rationalize the denominator of 4 plus root 2 times 4 minus root 2 all over root 7. Give your answer in its simplest form. So rationalize means to get rid of the surd on the denominator. Now, first step is I'm going to simplify the numerator first before I rationalize it. Now, some of you who are more observant here, or may know, yeah, obviously higher level, okay, that I've actually got the difference of 2 squares on the top. So all I'm going to do here is do this number times this number, and then this number times this number, okay, because the middle terms won't end up cancelling, okay, hence difference of 2 squares. Okay, again, yeah, if you're not sure, yeah, just obviously pause it and obviously check at this stage here, okay. I don't want to waste too much time, okay. Not that it's actually wasting time here, but I'm just conscious of, yeah, obviously, like, I want to try and make these grade 9 videos obviously quite succinct and to the point, okay. But yeah, okay, if you expand that, yeah, if you're unsure, you'll get 16, okay, minus 4 lots of root 2 plus 4 lots of root 2, so they're going to cancel, and then root 2 times minus 2, sorry, root 2 times minus root 2 is minus root 4, which is going to be 2. So we have 16 on the top minus 2 on the top, so we're going to have 14 over root 7, okay. I'm now going to rationalize this. That means to get rid of the surd on the denominator, so on the bottom, I do this by multiplying top and bottom by the denominator. So that times top and bottom by root 7 over root 7, okay. And you'll see why in just a second as to why I'm doing it. Okay, I'm multiplying fractions. I'm multiplying top by top, bottom by bottom. 14 times root 7, or 14 lots of root 7 makes 14 root 7. And on the bottom, guys, we have root 7 times root 7, which is root 49, which is just 7. Okay, I can obviously cancel down by top and bottom by 7. We get the answer of 2 lots of root 7. So 2 root 7. Because 14 divided by 7 makes 2. We get 2 lots of root 7. Okay, so I hope that, yeah, that actually makes sense here. So quite a nice question, I'd say. But yeah, if you're unsure, okay, I know I said, yeah, I don't want to waste any more time here. If you expand it, okay, on the top, you get 16 minus 4 root 2, so 4 lots of root 2, plus 4 root 2, okay, then you'll get positive root 2 times negative root 2, makes minus 2 and negative 2, okay, so it makes negative root 4, which of course is just 2, okay, and then if you collect like terms, okay, they end up cancelling, okay, difference of 2 squares. 16 minus 2 is 14. So if you expand that, the number you get at the end here is just 14. Okay, which obviously sounds a bit odd because obviously you've got some surds, But yeah, that is how the difference of two squares works. Okay, so if you ever hear me say dots here, okay, so difference of, so a squared minus b squared is equivalent, i.e. the same as a plus b times a minus b. Okay, in factorized form. Okay, so finally show that 4 minus root 3 times 4 plus root 3 all over root 13 simplifies to root 13. Again, I'm going to simplify the numerator first. So keep our denominator as root 13. Okay, so on the top, okay, similar to before, I'm going to do the first number times the first number, okay, and then this number times this number. So 4 times 4 makes 16. And then negative root 3 or minus root 3 times positive or plus root 3 makes negative root 9, which is or minus root 9 here, which makes minus 3. Okay, again, if you're unsure, okay, remember here, we also have here the difference of two squares, okay, here. Okay, if you expand it using FOIL, we are going to get 13. Okay, so you'll get 16 plus 4 root 3 minus 4 root 3, okay, minus 9. The 4 root 3's end up cancelling, so you get 16 minus 3, which is just 13. Okay, on the top. Okay, now to simplify this here, I'm going to obviously rationalize it. So I'm going to multiply top and bottom by root 13. So times the top by root 13 times the bottom by root 13. Okay, on the top, I'm going to have 13 times root 13. Okay, so remember, numbers go with numbers, surds go with surds. So that'll be 13 lots of root 3. So 13 root 13, sorry. On the bottom, root 13 times root 13 is just 13, okay? Is root here 169, which is just 13, okay? Because the square root here, obviously 169 here is just root 13, because 169 here is a square number, and we get 13, okay? So again, they're going to cancel, okay? I'm left with just root 13 over 1, which is just root 13, okay? As required, okay? So I'll put AR, so as required, or as shown, or AS, okay? So I think, yeah, very, very important topic, guys. Okay, you're looking at our surds. Okay, I think personally it's actually quite a nice topic here, as long as you're happy with your rules of surds. Okay, obviously expanding brackets here, knowing your surds. Okay, but remember, yeah, remember your rules of surds. Remember as well, yeah, that if I'm multiplying, so if I have root A times root B, I can put it on, yeah, inside one square root, or one root, so that'll be the root of AB, or BA, and then that also applies for you when I've got division here. So root A divided by root B is the same as saying root of A all over B, okay, or A over B, okay. And then, yeah, any other ones that I can think of, yeah, if I have here like root B all squared, okay, that just simplifies, yeah, just to B, okay, because the square root and the square, yeah, end up cancelling each other out, okay. That's very, very similar, yeah, not exactly the same actually, but that's very similar to writing the square root of B squared, which is just B. Okay, hopefully that makes sense.